Cambridge AS Computer Science, Chapter 3, Hardware. This chapter is mostly O-level. Because when we talk about hardware, we talk about input devices, we talk about output devices with little bit more of details. We talk about embedded systems, and this is now in the O level. We also talk about logic gates. Logic gates is a very interesting topic, and it is exactly as it is in the O level. However, if you haven't studied O level, I will teach you logic gates from the beginning in the AS. Okay, so let us start with hardware. You know that computer systems consist of hardware and software. Hardware are devices like keyboard, mouse, all the devices, okay? Input devices, output devices, storage devices, all of these are called devices. Let us start with the memory. The memory, okay? As a memory hierarchy is used to trend in important factors affecting the choice of memory. This factor increase in the direction of the arrow. Let us look at this diagram. Memory system. A simplified version of a memory system hierarchy is used to trend in the important factor affecting this choice. Factor increase in the direction of the arrow. What kind of storing devices do we have? We have a register. This is processor component. This is a component inside of the processor. And this is very fast. The capacity is very small. The size is very small. And its cost is very high. So access time is very little, which means it takes very little time to access data on the register. That's why the access time is very small. The capacity is, you have few registers and the size is very small, but the cost is very high. Then we have the cache. A cache is a memory between the processor and the RAM. It is little bit slower than the register, okay, and the capacity is little bit bigger and the size is bigger and less expensive. The main memory is the RAM of the computer, and it has longer access time, so it takes longer to access it. Its capacity is bigger, its size is bigger. I wonder what is the difference between capacity and size, but the cost is moderate, cheaper. So the main memory is RAM. And the cache memory is something in the processor that holds frequently used instructions. And then the hard disk is much slower than the RAM. However, its capacity and size is much bigger and the cost is much lower. This is the hard disk and is considered secondary storage that is not directly accessed by the CPU. The last thing, auxiliary storage, means removable devices. For example, a CD is removable. A pen drive, USB pen drive is removable. So they are slower than the hard disk. However, their capacities, the capacity of, for example, DVDs is unlimited because you can have so many DVDs or Blu-ray discs. So this is a comparison of memory storage devices. Let us go into the memory components. Let us study the RAM. Random access memory RAM and read-only memory ROM are both examples of primary storage. So RAM and ROM are called primary memory or primary storage. Random access memory RAM is volatile, which means loses data when the power is turned off. that can be read from and written to. RAM is read and write any number of times. There are two general types of RAM technology. One of them is stored in the RAM, is currently, okay? There are two types of RAM technology. They can be static RAM or dynamic RAM. We have two, okay? Okay, we have two. Let us move this here. Okay, or let us move. Let us move this here. One item that is stored in the RAM is currently running software, data, part of the operating system. Okay, so the RAM holds the running software and data and part of the operating system. Then there are two general types of RAM technology. Okay, RAM can be either static RAM, OSRAM, SRAM, or dynamic RAM, DRAM. SRAM use transistors arranged at flip-flops. DRAM use transistors and capacitors. We will be studying all these shortly. So static RAM use transistor arranged as flip-flops. Dynamic RAM use transistors and capacitors. We will be going through this shortly. Okay, so you already know what RAM is. The new thing is that we need to teach dynamic RAM and static RAM. This is the static RAM. This is the static RAM. And you will study that inside here. This is called RS or set reset flip-flop. Okay, so many things. Okay, so this is the static RAM. All these components just to store one bit, a 0 or a 1. The static RAM consists of so many components just to store one bit. This is the static RAM. And as you, maybe you can recognize that these are logic gates. Okay, so the static RAM consists of logic gates, okay, and they take a lot of components just to store one bit. This has so many benefits. It is very fast to read and write. And some other benefit, I will tell it after a minute. However, the static RAM is very fast to read and write. However, it's expensive because so many components just to store one bit. They thought of designing something else called dynamic RAM. So the static RAM is very fast. It doesn't need refreshing. We will talk about refreshing in a minute. However, it requires so many components just to store one bit. So the static RAM is expensive. Okay, they decided to invent another kind of memory. That another kind of memory is called dynamic RAM, DRAM. Okay, the dynamic RAM gets rid of all of these components and only uses a capacitor and a holding transistor. A capacitor to be charged or discharged to represent a 1 or 0, and a transistor to hold the charge on that capacitor. So the dynamic RAM is much simplified than the static RAM. The dynamic RAM is much simplified than the static RAM. However, it is not that fast to read and write like the static RAM. Also, it needs refreshing. What is called by refreshing? The charge on the capacitor leaks with time. The charge goes. And if the charge goes, ones and zeros will become the same. So every few milliseconds, the computer needs to refresh the data on the capacitor to maintain the static charge that represents a 1 or 0. So dynamic RAM requires constant refreshing. Okay, so let us go through this again. The static RAM is constructed from flip-flops. All these complex components are called flip-flops, which continue to store data indefinitely, while the computer is switched on, does not need refreshing. The static RAM does not need refreshing. Static RAM provides short access time, which means faster. But unfortunately, compares unfavorably with DRAM in all other aspects, is that it is more expensive. Okay? Okay. We will compare. The next type of RAM is the dynamic RAM. Is constructed from capacitors which leak electricity. So we have here the capacitor and therefore need regular recharging every few milliseconds to maintain the data stored. Dynamic RAM, DRAM, is less expensive to make. It can store more bits per chip, but require higher power consumption, which is significant when used in battery power device. It consumes a lot of electricity because of that discharge and recharge characteristics. The norm for cache memory is to be provided by SRAM. We do SRAM, we use SRAM in the cache, and the main memory will be constructed from dynamic RAM. Now we call it DDR. The RAM is called DDR. Okay, comes from dynamic memory. Okay, so the normal memory of the computer is made from dynamic RAM. The cache memory, which is inside the processor that hold frequently used instruction, the cache memory, which requires to be very fast, is made from the static RAM. Okay, and let us hold this comparison between dynamic RAM and static RAM. Dynamic RAM has to be refreshed and recharged. Static RAM does not. The dynamic RAM uses single transistor on the capacitor. The static RAM uses more than one transistor to form a memory cell. The static RAM has more complex circuitry. Dynamic RAM stores a bit as a charge. In static RAM, bits are stored using a flip-flop latch. The dynamic RAM uses high power because it requires more circuitry to refresh. The static RAM uses less power as no need to refresh. The dynamic RAM is less expensive to purchase as it requires fewer transistors. The static RAM is more expensive to buy as it requires more transistors. The dynamic RAM is slower access time and speed because it needs to be refreshed. The static RAM is much faster. The dynamic RAM has higher capacity. The static lower capacity because it is complex. The dynamic RAM is used in main memory RAM. The static RAM is used in cache memory. And that was another example does not need to be refreshed as the circuit holds the data while the power is switched on. This is the static RAM. Mainly used in cache memory of processor where speed is important. This is the static RAM. Has less complex circuitry. This is DRAM. Require higher power consumption under low level of air access. Significant when using battery powered devices. This is the dynamic RAM. Require data to be refreshed occasionally so it retains. This is the dynamic RAM DRAM. Then we need now to study the read-only memory ROM. Okay? Read-only memory ROM is non-volatile, which means cannot be written to, but can be read from many times. Actually, non-volatile means doesn't lose data when the power is turned off. Okay? So read-only memory ROM is non-volatile and cannot be written to, but can only read from as any number of times. The ROM is used to store basic input-output system, BIOS, and the startup instruction, the boot program, or the kernel of the operating system, the heart of the operating system. There is one part of the operating system that is involved directly in dealing with hardware components. This is called the kernel of the operating system. ROM is used to store for storage of data or programs that is going to be used unchanged over and over again. One of items that is stored in the ROM is the startup boot up instruction, the BIOS. Okay, so this is the ROM. ROM may be programmable ROM. The point is things are changing. So the ROM is read-only memory. Initially cannot be written to. However, there are newer versions of ROM. One of them is called PROM, which means programmable read-only memory. So it is writable. Programmable means data can be written to it. So ROM may be programmable ROM. But programmable ROM, you can write to it once and the data remains on it forever. Or erasable PROM, which means erasable programmable ROM. That can be erased, however, you need to take it off the device and put it under ultraviolet light to erase it. And the third enhancement is even electrically erasable programmable ROM, which means can be erased while in place. And this becomes the SSD. The electrically erasable programmable ROM recently became the SSD, the solid state device. These terms relate to the manufacture and installation of the ROM and does not impact on its basic use in a computer system. So you have electrically erasable programmable ROM. Then once there was a question that said, a very recent question, it said differences between programmable ROM, erasable programmable ROM, and electrically erasable programmable ROM. So what are the differences between them? PROM can be used once. PROM can be used once. Electrically programmable ROM, or erasable programmable ROM or electrically erasable programmable ROM can be overwritten multiple of times. So PROM can be stored, can be used to record data only once, and that recorded data may never be changed. However, erasable programmable ROM or electrically erasable programmable RAM can be used many times. Erasable programmable RAM needs to be removed from the device to be erased using ultraviolet light. So the erasable programmable RAM has to be removed from the device to be erased. However, electrically erasable programmable RAM can be erased in place. Also, erasable programmable RAM must be entirely erased before being overwritten. Electrically erasable programmable RAM can be erased in place using voltage as it is flash storage. Actually, it became the solid state drive. EEPROM does not have to be entirely erased before rewritten. That discussion was very recent in a very recent exam. Okay, so you have read-only memory, programmable read-only memory, erasable programmable read-only memory, then electrically erasable programmable read-only memory. Study this paragraph because I recently copied it from a very new post paper. Okay, so that was a bit about primary storage. Okay, memory component, that's the primary memory. Okay, now we go to the secondary storage, that is the hard disk. We have two types of hard disk HDD and hard disk SSD. Okay, there is a need for secondary storage. We need secondary storage because the use of only primary storage would be far too expensive. You cannot have a computer with only RAM. It's very expensive. However, it is more sensible simply to recognize that long-term storage of data requires separate dedicated components. You cannot keep your data in the RAM. You only keep the data on your hard disk. Okay? So this makes it necessary to have secondary storage, the hard disk. Okay, so you know all these. Even if you have studied ICT, you already know all this. Magnetic hard disk drive HDD. And then next, the solid state drive SSD. And we will compare their principles of operation. Okay? Okay. So magnetic hard disk. This is the most popular secondary storage device. The hard disk HDD stores data using magnetization. It has plates or surfaces like this, and the surface is divided into tracks and sectors, where the intersection between a track and a sector is the block, and the block is the smallest unit of data storage. You have several platters attached to a single spindle with read and write heads for every surface. So this platter has two surfaces with two read and write heads on the upper and lower surfaces. The spindle starts spinning and plates start spinning, and the read and write head moves in and out to access any data on any track or any sector on the surface of the disk. And data is stored in the form of tiny magnets that represent the binary data, ones and zeros. So hard disk drive HDD has more than one platter disk, and each platter has a read and write head for each side. The platters spin together. The read-write heads are attached to an actuator arm, which allow the heads to move. over the surface of the platter. The motion of each actuator head is synchronized with the motion of other head. So they are together on the same actuator arm. Okay, so this is the components of an HDD. The principle of operation of a magnetic hard disk. The hard disk has one or more platter. Each surface of the platter is ferrous oxide, so it is coated with ferrous oxide capable of being magnetized. The platters are mounted on a central spindle. The disks are rotated at high speed. Each surface of the disk has a read and write head, as you can see, mounted on an arm positioned just above the surface. Electronic circuits control the movement of the arm of the heads. The surface of the platter is divided to concentric tracks. Concentric tracks, as you can see in the diagram. Concentric tracks and sectors. One track in one sector is the basic unit called block. So one track in one sector is a block. Data is encoded as magnetic pattern for each block. North pole and south pole to represent the 1 and 0. Data is encoded as magnetic pattern for each block. When writing to disk, variation of the current in the head produces a variation in the magnetic field on the disk. So when you write, you send electrical signal to the head that causes some magnetization to be on the surface. When you are reading, the magnetization on the surface causes some electricity into the read and write head. So that was the principles of operation of the hard disk HDD. As you can see, you have moving parts, you have tracks and sectors, you have read and write heads, you have actuators, the spindle spins, platters. However, now they have recently invented the SSD with no moving parts at all. That device getting rid of all moving parts become much smaller, much quieter, less energy consumption, much faster to read and write. So the SSD has so many benefits compared to the HDD. Very soon we will study the principles of operation of the SSD. However, advantages of HDD compared to the SSD. Inexpensive. The SSD is more expensive. Larger storage capacity than flash drive. Larger storage capacity than the SSD. Has longer longevity, which means longer lifetime, reading and writing to it millions of times every day. So if you have, for example, a file server, you put a hard disk HDD. You don't put a hard disk SSD. SSD is faster, but it will not hold that vast amount of read and write. It will be broken soon because it doesn't have enough longevity. Okay, so let us move to the other one that is called solid state media or solid state drive. This is flash memory. It's a semiconductor technology with no moving parts. The basis for solid state media is flash memory, which is said to be a form of electrically erasable programmable ROM discussed earlier. Okay? But when this is used normally, not programmed in the factory. The technology used for solid state drives, SSD, can replace hard disk drive, HDD. The more frequent use is either for memory card and USB flash drive. So very soon SSD will replace the hard disk. However, it is now popularly used as a memory card or a flash drive. Next, how data is read from the flash memory. Before, we studied the principles of operation of the magnetic hard disk. Here, we need to study the principle of operation of the flash memory. It uses NAND-based flash memory. You should be familiar with NAND gates in the logic circuits that we will study a lesson or two ahead. So it uses NAND-based flash memory. And there are no moving parts. The SSD has no moving parts. It uses a grids of columns and rows, as shown here, that has two transistors at each intersection. One transistor is called the floating gate. The other one is called the control gate. Two transistors. The floating gate floats and stores the 1 or 0. The controlling gate makes sure that data is not lost when you want to keep it. So you have the controlling gate that keeps the data and a floating gate that may be either 1 or 0. Memory cell store voltage, which can be set to either 0 or 1. Essentially, the movement of electrons is controlled to read and write. It is not possible to overwrite existing data. It is necessary to first erase the old data, then write the new data in the same location. So that was the principles of operation of the hard disk SSD. And it has so many advantages over HDD. No moving parts and no noise. More robust, which means more durable. Low latency, so it reads data very fast. It doesn't have to wait till it spins at the normal speed. Disadvantage, more expensive, shorter longevity. So if you have a server, you would rather put a hard disk HDD rather than SSD. So you can understand now the principles of operation of a solid state drive SSD and benefits and drawbacks. So the SSD doesn't have a very high capacity of being written to and read from many times. Okay, so that's it about backing storage. Next, optical media, CDs, DVDs, Blu-ray discs, that all read and write using laser beams. CD-ROM is read-only because ROM stands for read-only. The read-write version, CDRW, provide the needed write functionality. DVD has larger capacity. The latest and most powerful technology is the Blu-ray disc. They all work using laser beam. So a laser beam is incident on the surface of the disk, and the reflected light is captured, and the reflection varies from bits and lines on the surface of the disk that represent ones and zeros. Okay? So the CD-ROM starts spinning, the disk spins, and a laser beam is reflected from the disk surface. The reflective surface has indentation. Those indentations represent called bits and lands, separated as what is referred to as lands. So those bits and lands represent ones and zeros. When the disk is being read, the travel, as you can look at this diagram, this is the disk, you incident laser beam, and then you measure the reflected signal. The reflective surface has indentation When the disk is being read, the travel of the laser beam to a bit cause difference in phase compared to reflection from a land. This phase difference is recognized by a photodiode. You have here a photodiode detector and attached circuitry and interpreted as ones or zeros. You use single spiral track. Anyone who has studied O-level computer science or even ICT is familiar with this. You have here single spiral track for CD or DVD. However, DVD RAM uses concentric tracks to allow reading and writing back to be performed together at the same time. Principles of operation of a DVD-RW. It uses a single spiral track, as you can see, that allow write or read operations to occur as separate operations, not both at the same time. In order to read new data to the disk, the existing data must be completely erased. Performance degrades and become unreliable after several read-write cycles. Single-sided is 4.7 gigabyte capacity. DVD RAM allow reading and writing to occur simultaneously. Why? Because it has concentric tracks. Data is stored, written using laser beam. Allow read and write operations to occur simultaneously. Make the use of sectors to store data, just like the hard disk. Repeatedly read-write cycles and erase are possible. Double site 4.7 gigabyte capacity per site. Okay. Then the most popular one, the best one right now, is the Blu-ray disc. The Blu-ray disc uses blue laser. Here we use red laser. Okay, so the CD and DVD uses red laser. The Blu-ray disc uses blue laser that have shorter wavelength. This change in one wavelength is one of the reasons for the improvement in the storage capacity of modern technology. It includes digital rights management, so you cannot pirate programs on the Blu-ray. They use encryption tools to prevent software piracy. Okay, so how far should we go? We shall study all these devices. Okay, next we have computer mouse. In old days, we used to have a mechanical tracker ball mouse with a ball underneath the mouse to measure its movement. But this is phased out, and the optical mouse with sublight underneath is introduced. So the optical mouse, or let us call it the laser mouse, there is some laser LED underneath the mouse, and when you move the mouse, there should be some change in the area under the mouse, and the reflection is captured by a sensor. So laser light shines onto a surface, the surface below the mouse, through a polish ring at the base. The light is reflected from the surface through the rings, and sensors detect light capturing details or photograph of surface under the ridge about 1,500 times a second. So it is like there is a camera, a very small camera underneath the mouse capturing the change in the area under the mouse. As the mouse moves, the sensor detects changes in the surface or photograph which are transmitted into movement, change of XY coordinate. the computer software updates the position of the cursor on the screen. So when you move the mouse, the arrow on the screen moves. Okay, next, another hardware device. So we are studying here plenty of hardware devices. We have the screen display. We have the screen display. We have LCD display, liquid crystal display. Okay, is a screen backlit by light emitting diode. So the backlight of the screen is light emitting diode LED with liquid crystal cell. So we have the LCD stands for liquid crystal display. So we have liquid crystal cells that represent pixels of the picture. The liquid crystal display LCD has individual cells that contain a liquid crystal to create the pixel. Every cell is just one pixel and they do not emit light. The light comes from the backlight. Lighting emitting diodes at the back providing backlight. And there is a layer here of liquid crystals that generate the picture. Liquid crystals do not emit any light. However, they have white backlight at the back. And then they form the image, and there is a polarizer, which is a kind of filter polarizer to make the color or the picture vivid and easy or nice looking. So the liquid crystal display LCD has individual cells containing a liquid crystal to create the pixel matrix, but they do not emit light. The pixel matrix is illuminated by backlighting, and each pixel can affect the transmission of this light to cause the on-screen display. Okay, so this is the LED or LCD. A very recent technology is called OLED, which comes from organic LED, where pixels emit light. So the OLED, organic light emitting diode, is used directly as a light source. It emits light. So this technology requires no backlighting. So you have LCD, LED, and then OLED. Next, we have the touch screen. Now we study the touch screen. The touch screen is considered as both input and output. Actually, it's an output device on which input can be entered because it's a screen, so it's an output device. And it is touch, and the touch registers the place you touch to, for example, to select the application like you are doing or using your smartphone. Okay, so there have been two approaches used for touch screen. There are two technologies used for touch screen. The first is resistive touch screen. The second is capacitive touch screen. This is the resistive touch screen. Look at this picture. The touch screen, the screen is a bit flexible. When you touch it by your finger, you make the upper surface touches the lower surface. And this creates or completes a circuit inside the screen where data, where electricity moves, creating a voltage or voltage divider. Okay? So with resistive touch screen, you press the screen and make the upper part touches the lower part, and according to coordinates, some voltage or some signal can be detected. This is called resistive touch screen. Depends on making the upper layer touches the lower layer, completing a circuit. There is another technology used with touch screens. This is called capacitive touch screen. where your finger as a conductor, when it touches the surface of the screen, some electrons jump into your finger, or the electrostatic field is modified by the presence or your touch with your bare fingers, and there are sensors that detect that disturbance in the charge, and then the touch is registered. Okay, so you have resistive touch screen, you have capacitive touch screen, and a comparison between them. You need a comparison between them. Okay, so resistive touch screen has a flexible surface which causes contact between electrically resistive layers beneath when touched. This type has two layers separated by a thin space between the screen surfaces. The screen is not rigid, so when a finger presses on the screen, the pressure moves the topmost of these two separate layers, so it makes contact with the lower layer. The point of contact creates a voltage divider in the horizontal and vertical directions. This allows the position of the point of contact to be determined and transmitted to the processor. This is how the resistive touch screen works. The capacitive touch screen has a bit different technology. It has rigid surface, which undergoes a change in electrical state when a finger touches the screen. So some disturbance of charges or magnetic field around the screen. This does not require a soft screen. Instead, make use of the fact that a finger touching a glass can cause a capacitance change in the static field, in the charge. Okay? Immediately below the screen. The most effective technology is projective capacitive touch, PCT, which with mutual capacity. This has a circuit beneath the screen which contains an array of capacitors. This enables multi-touch. The capacitive touch screen allows multi-touch, which allow more functionality than just pointing or locating. Let us read this example. A car has a resistive touch screen for the laser to select options. The screen always have 5 different layers. This is false. A processor determines the horizontal and vertical coordinates of the point of contact. This is true. The touch screen will work if any object touches the screen. This is true. Okay, شباب.